Hello students, welcome to chemistry class. In our last class, we looked at laboratory preparation of salt, where we said that salt can be prepared by the reaction of dilute acid with metal, also by the reaction of acid with alkalis, and also by the reaction of constituent elements. In today's class, we are giving attention to salt terminologies, and your presenter is E.B. Christian. All right, let's look at salt hydrolysis. Salt hydrolysis is a reaction involving use of water to break bond in salt, forming acids and base. Look at this reaction. A reaction in which water is added to a salt to break the bond, forming a base and acid, is called salt hydrolysis. You can see this reaction here. 2 molecules of aluminum chloride reacting with 6 molecules of water to give you 2 molecules of aluminum hydroxide and 6 molecules of hydrogen chloride. The nature of the reaction is that the bond between aluminum and chlorine will be cleaved, will be broken, giving aluminum a positive charge and chlorine a negative charge. The bond also between hydrogen and hydroxyl will be cleaved, giving hydrogen a positive charge and hydroxy a negative charge. So the next thing is for them to exchange their charges such that the aluminum of positive will be attached to the hydroxide that is negative, and that forms aluminum hydroxide. Next, the chlorine that is negative will be attached to the hydrogen that is positive, and that forms hydrogen chloride. Okay. Another example is the reaction of ammonium chloride with water to give you ammonium hydroxide and hydrogen chloride. So ammonium chloride is a salt, while water is the hydrolyzing agent, and then ammonium hydroxide is a base and hydrogen chloride is an acid. The next example is zinc tetraoxosulfate 6, which is a salt. In the presence of water, it forms zinc hydroxide and tetraoxosulfate 6 acid. The last one we have here is copper 2 tetraoxosulfate 6, which is a salt. In the presence of water, it will be hydrolyzed to give you copper 2 hydroxide and tetraoxosulfate 6. The next terminology we are considering is efflorescence. A phenomenon where crystalline salt loses all or part of its water of crystallization on exposure to the atmosphere is called efflorescence. The salt itself is termed efflorescence. Examples include sodium trioxocarbonate 4 decahydrate, otherwise called washing soda. You can see the formula there in red. This is sodium trioxocarbonate 4 decahydrate. It loses 9 molecules of water and becomes monohydrated. Also, sodium tetraoxosulfate 6 decahydrate, otherwise called global salt, will become anhydrous on exposure to the atmosphere. Look at their reaction now. Now this is sodium trioxocarbonate 4 decahydrate having 10 molecules of water. On exposure to the atmosphere, the water will evaporate. It will lose out 9 molecules of water, remaining only 1, and become monohydrated. So we call this sodium trioxocarbonate 4 monohydrate. Okay, good. This is sodium tetraoxosulfate 6 decahydrate containing 10 molecules of water. This other salt will give out on exposure to the atmosphere all the 10 molecules of water and become anhydrous, that is water free, completely absence of water. That's what we have here. Sodium tetraoxosulfate 6, there's no water here. Then this is the 10 molecules of water that is liberated. The next terminologies we are considering is deliquescence. Deliquescence is a phenomenon where some compounds absorb large amount of water from the atmosphere to the extent of dissolving to form solution when exposed to the atmosphere. The compounds that exhibit this phenomenon are called deliquescents. They are used as drying agents. Example is sodium hydroxide, iron 3 chloride, potassium hydroxide, calcium chloride, magnesium chloride, phosphorus 5 chloride, and as well as what? Silica gel. Now let's see the next terminology being hygroscopy. Hygroscopy. What is hygroscopy? Substances that on exposure to the atmosphere absorb water, but not to the degree of dissolving to form solution, are termed hygroscopic substances. This phenomenon is called hygroscopy. Solid hygroscopic substances will become sticky or moist on absorbing water, while the liquid ones will absorb water up to 3 times the original volume. Examples of hygroscopic substances include tetraoxosulfate 6 acid, you can see it here, sodium trioxocarbonate 4, copper oxide, and as well quicklime. And you know that quicklime is calcium oxide. The last terminology we are giving attention in today's class is dessicants. What are dessicants? Dessicants are otherwise called drying agents and are substances with great love or affinity for water. That means they love water, they like water. Okay, good. Their key function is that they are used in drying laboratory gases. Dessicants are either deliquescent or hygroscopy. Must be unreactive throughout the gas it dries. Otherwise, it cannot be used for that purpose. For instance, sulfuric acid cannot be used to dry ammonia, as it reacts with the gas to form ammonium tetraoxosulfate 6. So this reaction here makes sulfuric acid not to be used to dry ammonia. Look at 2 molecules of ammonia combining with tetrasulfuric acid to give you ammonium tetraoxosulfate 6. Thanks for watching. Do well to do your assignment and submit to my private line.